Hello teacher and everyone. We are from Group CA. Today, we would like to present our project on Ratchet mechanism, which is significant mechanism that apply in various fields and industry. First, let's introduce ourselves. My name is Chayapon Ponggun. Student number 6601001621.
My name is Trailak Yammee. Student ID 6601001621. We both come from Group CA, and the topic we will be presenting today is the Ratchet mechanisms.
To start, let's understand what ratchet mechanism is and how it works. The ratchet or gear system is a mechanical mechanism that allows movement in a linear or rotational direction in only one way. It prevents movement in the opposite direction, which makes it crucial in tools and machinery. Whereas precise control of movement is necessary, such as adjusting device safely in one direction.
Ratchet mechanisms are used in tools like the socket wrench or clicking wrench, which we will discuss later. Ratchets are common in daily life because of their special feature of controlling the direction or rotation of movement, which explains why they have been widely used for a long time.
Now, let's talk about the history of the ratchet mechanism and the person who invented it. The ratchet mechanism was invented and developed by J.J. Richardson, an Italian inventor known for his outstanding work in tool making. Richardson was born in Woodstock, Vermont, Italy, and he is patented his mechanism on June 1863, and as the inventor and improver of the ratchet wrench, which has been a highly useful tool in many mechanical industries.
The development of the ratchet mechanism during that time was a significant step in the tool industry. This mechanism wasn't only popular in Italy, but was also widely used in many countries around the world in construction, factories, and maintenance industry. Richardson's ratchet wrench is a clear example of how a simple yet efficient idea can create a massive impact in the industry.
Moreover, the 1863 patent marked the beginning of continuous improvement of ratchet mechanism, which had evolved into highly versatile and efficient mechanism to meet the diverse needs of different professions.
Now let's move on to the principle of operation of the mechanisms. The ratchet mechanism consists of a gear or line rack with a symmetrical teeth. Each tooth has a different slope, where one side is steeper than the other. Additionally, there is a cord which is pushed by a spring that grips the gear teeth when moving in the lock.
The ratchet mechanism operates in a simple yet entirely complex ways. When the gears move in the unrestricted direction, such as forward rotation, the power smoothly pass over the gears with the lower slope, create a quick sound which is good pass. However, if the gear attempts to move in the opposite direction, the power will immediately engage with the gear teeth, preventing any backward movement. This is the principle that allows the ratchet mechanism to control movement in the only one direction effectively.
Apart from the power and gear, there are other components such as the spring, which push the power into the gear teeth, and the base support, which keeps their mechanism stable when not in use. A well-designed ratchet mechanism must ensure smooth operation and durability for long-term use.
Now let's take a look at some everyday application of the latches mechanism. First, socket range. This tool is used in general maintenance tasks. The latches mechanism allows the range to turn in one direction and easily return without need to remove, making the job faster and more convenient. It also improves accuracy when tightening bolts and screws, because the location direction can be efficiently controlled.
Second, curving hoist, a device used for tightening cable. The ratchet mechanism is used in hoist to pull cable in one direction and lock them to prevent backward movement, ensuring safe and efficient operation. It also reduces fatigue when pulling heavy cable. Third, cable tie, zip tie, or strap that we often use to fasten wire or other objects. For net. Ratchet mechanism is used in the cable tie so that they can be tied tightly and cannot be loosened without additional tool, which make managing wire or various material is easy and fast.
Fourth, bike chain. The latches mechanism is used in bicycle gears to allow forward pedaling and freewheeling when not pedaling, making the ride smoother without resist from backward rotation. Fifth, turn cars used in places like train station to control the flow of people. The latches mechanism prevents reverse movement, helping manage access to area effectively and safely.
Theory of the ratchet mechanism, we give three examples. Unidirectional motion. The ratchet wheel is designed to move in only one direction. It cannot rotate backward because the power lock the wheel when trying to reverse. And the second theory is friction and slipping. This mechanism uses friction between the pole and the teeth of the ratchet wheel to prevent backward movement. A flexible pole design helps reduce wear and increase the lifespan of their mechanisms. Third, force control. The power must be designed to handle the force applied by the rotating ratchet wheel. If the power is not strong enough, the mechanism could wear out quickly.
Now let's talk about design of the latches mechanism. Design the latches mechanism requires consideration of several factors such as first, teeth of latches wheel. The teeth of the latches wheel should have the correct shape and angle to effectively prevent backward rotation. Typically, the teeth are angled in the direction of desired rotation. Second, power. The powers must be strong and flexible enough to securely lock the latches wheel when it's time to rotate backward. There are two types of power. First, active power. That is power that works with external force like spring. Second, passive power. This power that works by the force from the latches wheel rotation.
Third, tooth angle. The angle of the teeth affects how much force is needed to rotate the wheel. A smaller angle reduces resistance to rotation but increase the risk of wear. Fourth, material selection. The material used for the ratchet wheel and pole must be strong and able to resist friction, Common material includes steel or high-strength material. Next, calculation for designing the ratchet mechanisms. The calculation for designing the teeth and ratchet wheel involve several steps. It depends on their design, operation, and factors like their number of teeth, tooth angle, and the force acting on the system. Here's an example of a tooth angle design calculation based on the actual workpiece.
Our tooth height is 0.009 meters. Our tooth bed width is 0.015 meters. The tooth angle is calculated by using the formula that is theta equal arctan h divided by b. After that, we substitute the value we get from the equation. Theta equal arctan 0.009 divided by 0.015. So, as you can see, we got out theta equal 30.37 degrees. This angle falls within the suitable range of ratchet teeth, which should be between around 30 to 45 degrees. Now let's discuss the process of building our ratchet mechanism model, which we divided into 6 main steps. First, 3D and 2D designing. We use SolidWorks to create both 3D and 2D designs of the model. This step is crucial for planning everything accurately for the production. We ensure that all the components are correctly sized and proportioned.
Second, pre-dimensioning in 2D. The 2D design is used to specify all the measurements for production, like length, width, thickness, and necessary angle, so that the final product match the design. Third, we laser cutting the acrylic sheet. After finalizing the design, we use laser cutting machine to cut the acrylic sheet. The laser cutter allows us to produce the crisp part according to the design, and it also saves time and minimizes error compared to manual saw cutting.
Fourth, with 3D printing. For some parts, we use a 3D printer to create components with complex shape and hard to do with machining. 3D printing allows us to customize the part before final assembly. Fifth, surface treatment and machining. After producing the part, we smooth the surface, remove any unwanted edge, and ensure all the components fit together perfectly. This finishing step is crucial to ensure smooth operation and high quality output.
The last one assembly. Finally, we assemble all the parts and test their mechanism to ensure its friction as design careful assembly was required to make sure all parts fit well and their mechanism operates smoothly. We also clean off any dust from their process to prepare it for submission to their instructor. And this is our workpiece that we simulate motion from SolidWorks.
And this is our workpiece that we create. As you can see, there are 2 steps of plan. First step is rotating the back gears in only one direction, clockwise. And in the second step, it turns the front gears in the counter-clockwise direction only. This workpiece shows that the ratchet mechanism is allowed to turn in one direction only.
Now let's talk about regarding cost. We divided their budget into the following categories. First, acrylic material. The acrylic is 20 mm thick and laser cutting costs us about 2,300 baht for producing the part. Second, bushing to ensure smooth rotation, we spend around 300 baht on high quality bushing to reduce wear on the part. Third, 3D printing costs here for the part and the plastic filament used for printing amount to 780.
Fourth, spring that pays against the top cost us 80 baht. Fifth, for bolts and heel and screw cost about 40 baht. And the total cost for build the ratchet mechanism is approximately 3,500 baht.
Now let's conclude what we gained from this project. Studying and experimenting with the Ratchet mechanism has given us a deeper understanding of this mechanism, not just theoretical but also just hand-on experience in design and building the model. This mechanism is beneficial in many areas and can be applied to various industries. Building this project not only requires skill in design and manufacturing but also teamwork, time management, and budgeting to ensure successful competition within their set time frame. We also learn the importance of careful planning in designing the Ratchet mechanism, using SolidWorks to define the dimension and proportion to ensure smooth movement and operation. Different design of the Ratchet mechanisms suit various application on although they may share similar principles.
The knowledge and experience we gain from this research will be useful in further projects, especially in designing and developing more complex mechanisms, and apply them effectively in different industries and professions.
We hope that the information and project we present will be useful to everyone, and we would like to thank our instructor and all classmates for listening.
Thank you.